Hey guys, Professor O'Brien here, and we are on to the section of this course where we begin to apply our knowledge of technology and language to the global environment, which is to say, we've been working more or less in an English only environment in this class until now. We've recognized the existence of other languages, but we haven't really dealt with them. And in a course entitled Language and Technology, a course that directs itself as much to the linguistics side of language and technology as to anything else, it seems a pity, it would be a pity to ignore the presence of hundreds of other languages around the world, which are receiving or which need support from technology. It's a fiction to believe the United States is an English-speaking country. It never was. The founding fathers were, yes, predominantly English-speaking, but the newly independent United States of America in 1776, or more realistically, the 1780s, was French-speaking in the South, Dutch-speaking around New York, German-speaking around Philadelphia, and we always conveniently forget the presence of Native American languages. The United States has always been a multilingual nation, and we forget that at our peril. And it is it is simply wrong to demand that the United States become a monolingual entity. It's not what the country is. In that list, I have forgotten to mention Spanish, which is de facto the United States' second official language, which is pretty much the only language spoken in Puerto Rico, whose residents are considered American citizens, and a language that is spoken widely in Florida, California, Arizona, and other southern states. And I need not mention the huge prevalence of Spanish in America's big cities, which often retain their Hispanic heritage in their name. Los Angeles, San Francisco, El Paso. These are all originally Spanish-speaking locations, and you can see that from the names. Some states, even some states, were originally named by Spanish speakers, such as, for example, Florida. All right. That pretty much covers the first page or two of the PDF that accompanies this lecture. You'll even see that we still have a little bit of Dutch here in the New York area when we sit on our stoops and eat cookies. You may not be aware that native languages are still spoken on the east coast of the United States. There's a very heartwarming documentary publicly available on the revitalization of the Native American language spoken in the Plymouth, Martha's Vineyard area of Massachusetts. And even here in New Jersey, there is an active Native American tribe called the Lenni Lenape. They are not recognized by the state of New Jersey, but that's no surprise. Nor are they recognized by the federal government, but they exist. Now, their language is extremely weak, but there they are. Now, one of the thrusts of this lecture, or this unit, is how, and this is unavoidable and it isn't something to apologize about or feel shame about, but how Anglocentric, or perhaps at least Eurocentric, language technology is. Now, people see this as some sort of innate bias, but it seems more likely to me that first past the post wins. And the first communities to develop um, advanced language technologies over the past 500 or 600 years have been European or Western. Um, now, that's not to say that language technologies haven't developed independently of others, but those that are more cumbersome tend not to uh, develop the uh, um, advanced technologies that others have developed. So you will see, or if you were to research the matter, you would find that there were rudimentary forms of printing available to the Chinese and the Japanese in the late Middle Ages, early modern period. But their languages, or at least the way they wrote their languages, did not lend themselves to easy printability. And this was because their languages, their written language was pictographic, which made it very difficult to develop printing presses that would be readily resettable for the publishing of books, newspapers, pamphlets, and so on. But if you had the time and the energy, you could certainly carve a printing plate and print something in those languages. And we actually do have printed material from that period, from Asia. However, the real development in language technology centered around alphabet-based systems. If you think about that, you're talking about Hebrew, Greek, Latin, and so forth. Languages being spoken in the Mediterranean area. Now, the reason alphabet-based systems lend themselves so easily to technological development is because typically an alphabet-based language might have no more than 20 or 30 characters, which can be recycled and reused. Hebrew has 22 characters, English has 26 characters, other European languages have about the same, Russian has about the same, Greek has about the same. So you have the idea. It was really about the year 1450 with the invention of the printing press in Germany that the alphabet-based languages came into their own. Now, you might not recognize, you might not think about this, but if you're speaking any European language, Spanish, English, French, Dutch, Swedish, Italian, Portuguese, you're using an alphabet that was originally being used for Latin 2,000 years ago. And the only reason that alphabet has remained in use is because of Christianity. After the Roman Empire, after the Latin-speaking Roman Empire Christianized, they proselytized outside their borders and inside their borders using a Latin-based Bible. And it was access to scripture, really, that made, or it was a perceived need to have access to scripture that led to an increased public interest in reading and writing, because otherwise, how were you going to get access to the scriptures? So most European languages by 1450, not all, by the way, because Russian and Greek and several others used other alphabets, but most European languages used the Latin alphabet, which they adopted from the Roman Empire. even as the Roman Empire was collapsing about the year 450. Now, the genius of the Latin alphabet is that it's easy to learn. You only need to learn somewhere between 20 and 25 characters. After that, you've learned the alphabet. Not so for Chinese or Japanese, where you might have to learn hundreds or thousands of characters. As we see on page 4 of the handout, to print a letter on a page, all you have to do is carve a printing block, a character block, ink it, and press that on the water, on the paper, and you get a printed letter. You can then take that block out and reuse it. And that's where the real genius comes in. All you need is a heap of letters and the ability to put them together and press them onto paper. And you are able to print a page and reprint a page. And if you think about it, it's multiplicity and reusability that makes the printing press genius. You can't just print a single page, you can print 100 pages. And after you've printed those 100 pages, you can break up your collection of letter blocks and reuse them to print another page. Now, think about this. As you can imagine, the printing press had its greatest impact in European languages that were using the Latin-based alphabets. But it was easily adaptable for other alphabet-based languages, such as Russian, Greek, Hebrew, and so on. But it wasn't so readily adaptable for pictographic languages, like Chinese, for instance. So what happens in the aftermath of the invention of the printing press is that Latin-based alphabets spread widely because of all this printed material being distributed. But logographic languages flounder. It might amaze you to learn that typewriters, for instance, which was about the only way you could print in those languages for Chinese and Japanese, were only invented in the 20th century and were impossibly complicated because of the number of characters involved. Now, this gives us a 500-year period, really, that is, well, let's say 400 years, between the year 1450 and, let's say, 1850, where alphabet-based languages sweep the world. The printed material in these languages is readily available, disseminates easily, and you often find, in fact, for instance, among missionaries, that when they come across logographic languages, they will actually, just to make the printing of Bibles easier, they will create an alphabet for those languages simply so that they can print off Bibles in those languages, which is possibly one of the reasons, for example, Vietnamese, of all languages, uses a Latin-based alphabet. You can see, if you ever see Vietnamese, that there's a great deal of extra material around the letters in Vietnamese, but it is fundamentally Latin-based, which indicates that Vietnamese was first printed by Europeans, not by Asians. Now, we have in the early 19th century, early 20th century, the development of computers, but it's really only the 1930s, 1940s, and probably the added kick of the Second World War that gives Western powers, who, as you will remember, were victorious in the Second World War, the impetus to develop computers. But as you can imagine, with Europe and great portions of the rest of the world in ruins, the only countries that where there was really any headway being made in the development of computers in the aftermath of the Second World War were the United States primarily, and then secondarily the United Kingdom, Canada, France, and to a certain extent Russia and the Soviet bloc. However, the rise of the Iron Curtain and the rise of totalitarianism on the eastern side of the Iron Curtain meant that developments in computing over there were not quite as rapid as developments elsewhere. Now, France aside, you can imagine what's going to happen if computing, particularly where language is involved, develops in areas that are primarily English speaking, and that's the United States and the United Kingdom. We get computer systems that are fundamentally English based. And even now, in the 21st century, we have people developing computer languages, and I'm thinking, for example, of Python, which was developed in the Netherlands, not in the United States or the United Kingdom, but which are being developed in English. Any of you who has learned how to code in Python will know that that language is English-based. Why is that? Why didn't the developer of Python choose Dutch as Python's primary working language? Because he saw the power of English in the Western world or globally, and knew that for his language to catch on, it was going to have to operate through English and not through some other language which does not have global reach. Now, how do computers connect with language? Well, we've spoken about corpora in the past. And I would argue, in fact, that it was the developing nexus of computing power and language that really gave provided the great step forward for the internet and communication using technology. But this means that language needs to be standardized. That alphabet-based system, and remember, we're talking about an alphabet-based system again because most computing is being done in English. It has to be standardized. If you're going to write a word on your computer and have that word show up on your friend's computer, you're both going to have some sort of a standardized system to turn those ones and zeros back into the word that you want. And that means that you need to develop an encoding system so that if I press A here, which causes a series of zeros and ones to be spat out, when that set of zeros and ones is fed into my friend's computer, the letter A comes back out. So there has to be a standardized system. And what developed in the 1950s was ASCII. Curses, I cannot remember the what ASCII stands for. I believe it stands for American Standardized Code, something like that. But ASCII was a 7-bit system. Now, all it means when you say a 7-bit system is that you're using binary code to encode your letters, and 7 bits is 2 times 2 times 2 times 2 times 2 times 2 times 2, and that comes to 128. So using binary code, you can encode 128 characters. Now, that's fine for, let's say, English, where you only have 26 lowercase characters, another 26 uppercase characters, numbers, and then all the rest of the material you'll see on a typical computer keyboard. But by the time you've got the squiggles and the carets and the ampersands and the colons and so on in, you've used up all your 128 characters, and there's no space left for things like the Spanish ñ or the German Eszett. So what you had from the 1950s right up until the 1990s is a very English-based language encoding system. Now, other languages, particularly alphabet-based, did develop transliteration techniques, but transliteration typically means non-standard. And that meant that if you were to type something on a Russian computer, you would get gibberish when you fed that code into an American computer, because the standardization systems were not the same. Now, I say on page 6 of the handout, as long as memory remained expensive, and it did right up until the 1980s, ASCII remained standard. Now, that might not be clear. It might not be clear to you why, but if it costs money to store more bytes, you have no incentive to store more material. You want to cram as much as you can into as little space as possible. The only way to encode other languages is to extend. And I use the word extend because from about the 1980s on, we get what's called extended ASCII. And that means we get those 7 bits, meaning 128 characters, plus an 8th bit. And that 8th bit means you now have 256 characters. And extended ASCII was typically used to allow extra characters in, to send up flags that the text is in another language. But the problem with extended ASCII is it was adaptable for whatever system it was being used in. So IBM might have their own extended ASCII, the Brazilian government might have their extended ASCII, and the German government might have their extended ASCII. Now that's absolutely fine if all you're using is the characters in the 7-bit code, but you're in the Wild West when it comes to characters beyond that. Who knows what sort of character you're going to get if you encode Eszett in German and then feed that binary code into an American computer, because it isn't standardized. Now, it literally took until the 21st century before this problem was resolved. And that was resolved through the establishment of the Unicode Consortium. The Unicode Consortium basically encouraged corporations and governments to come together and agree on a single encoding system. And the Unicode system, which isn't still hasn't been accepted 100%, which is often the reason you will find strange characters on a web page, and I'm sure you have found that yourselves. Unicode is scalable. If all you need is a single character from the 128, you'll be using those 7 bits. But if you need more, you'll use the 256, but in a highly standardized way. And then if you are going outside that system, perhaps to an African language, Asian language, you will actually use an entire second byte. Now, it occurs to me that I've been a little cavalier with my use of the word bit and byte. We have explained it earlier in the course, but I'll explain it again. A bit is a unit of binary code. It's either a 0 or a 1. A byte, however, is a unit of ASCII code. That is to say, it is either 7 bits or 8 bits. That means when you speak of a bit, it's always either 0 or 1. When you speak of a byte, it can be anything from the value corresponding to the number 0 up to the value corresponding to the number 256, or 255, in fact. Other alphabets need 2 bytes, 3 bytes, or even, well, Unicode has only encoded languages up to the 3rd byte at this stage, but they do make the 4th byte available. No human languages are using them yet. 3 bytes will allow up to, and I'm just going to have to translate a large number here, 16,777,216 characters. That represents pretty much any human language you can think of. The principal form of Unicode is UTF-8, and 90% of internet traffic, or more than that, is now encoded using UTF-8. Now that we have a globally compatible system, we find ourselves in a world where we can encode even minority languages. And on page 7, I give examples such as Scottish Gaelic or Irish Gaelic, which don't have a great deal of speakers and yet have enterprise software such as LibreOffice and the Microsoft Windows 10 operating system available. Well, Irish Gaelic has that, Scottish Gaelic not yet. So what we have essentially is, although it has taken 60 years and more, we have a computer system that recognizes the existence of other languages and allows them to be encoded in such a way that however you want to encode your language, as long as it is encoded in a standardized way, somebody typing Navajo in the southwest of the United States is still practically certain that when he feeds that text into his computer, that somebody in Russia will see Navajo on his screen when that text gets fed back in. So that's all I want to say about the internationalization of language and working in a foreign language. You'll see there are several exercises associated with this project, and I'm just going to scroll down here. I'm asking you basically to convert your operating system to another language. Please use common sense, use a language you are familiar with, even if only partially, because if you change your operating system to Chinese, for instance, and you don't speak Chinese, getting back into English is going to be extremely difficult. I'm also going to ask you to install an Office suite in another language. That Office suite can be Microsoft Office if you wish. It's freely available to William Paterson students. Or LibreOffice, which is an open source Office suite, and it's available in, I believe, more languages than the Microsoft Office suite is available in. I am going to ask you to change the interface language of your smartphone into another languages as well. And I'm going to ask you to make screen captures and upload those screen captures to the relevant spot on Blackboard. So thank you very much for your attention, and we will be talking again soon, I hope.